Hey guys, welcome back to a new video. In today's video, we're looking into uh, in the previous video we talked about the classification of carbohydrates. Like we looked into, we have got monosaccharides or the oligosaccharides and the polysaccharides. That was the classification of carbohydrates on the basis of saccharide units, and saccharides are the constituents of the carbohydrates. Now in today's video, we'll be looking into the classification of monosaccharides. Like we have got further classification of each of them, and we're looking into classification of monosaccharides. On what basis we're looking into the carbon atoms basis. Like the saccharide unit, like this is monosaccharide. Do remember this is monosaccharide. That should be a one sweet unit, but that one sweet unit can contain 3 to 7 atoms or atoms of carbon, and I mentioned this point in my previous video as well. So we have got a classification on that basis. Like we have let me write the general formula of like we have got this general formula uh, of monosaccharides or the carbohydrates. Sorry, CN, H2N, sorry, H2N and ON. This is a general formula. Like if you can take the example of uh, carbohydrate, or sorry, glucose, like C6H12O6, C6H12O6. So you will get to know that this is when we will simplify it, you will get to know that this is the same which this cut them all, and you will find a CH2, H2N, CN, H2N, uh, like N is the number of atoms, and N is N in glucose is 6, and N is 2N. 2N means 12, and here we have got oxygen. It is 6. It is also N. So this is how you're gonna make the formula, but you just need to remember this formula. And do remember that we have not only glucose, we have got other things as well. uh, Glucose is kind of a say monosaccharide that is based on 6 carbon atoms. We have got a group of 6 carbon atoms that is not having only glucose. We have also got other structural differences on what the structural differences that will make glucose similar molecules, and that would be very similar to glucose. That would be just a single atom arrangement difference. So don't take tension about that. We're looking into one by one, and we are going into the series step by step. Today we are looking into, like, what if we put here, like we know this n value is from 3 to 7. So what if we have the carbon number 3? What would be this ratio, and what are they forming? What would be it is 4, 5 and 6 and 7. So I would take a break for making the table and saving a bit of your time. Let me come back. Okay, so I'm back with the table, and uh, that seemed quite confusing. Like neutrons are there, the aldoses and ketoses. What's that? So don't panic about that. We're looking into that as well. They're very basic and very important as well. Uh, so first of all, as we know that the general formula. First of all, let me write the general formula: C and H2N. Like whatever would be C, the double would be H, and the same would be oxygen, or ON, right? So here we have got tri, right? This is tri. So from here we get to know that the formula would be C3, right? Tri. And we know that the hydrogen is double, so hydrogen would be 6, right? Hydrogen is 6, and oxygen is the same. Oxygen is the same. So the trios is which is okay. We have got 3 to 7, like 3, 4, 5, 6, 7. And this is the carbon atoms, and on this basis we are doing the classification. Like 3, we put that value in the general formula, and we do get to know that this sort of monosaccharide is present in which the carbon number would be 3. So that would be trioses. Tri means 3. So trioses. uh, we are not going into aldoses and ketoses right now. Leave this section. At the last we will discussing it. We've got tetrosis. Tetro means 4. We've got C4. Double the value and we will get H8. H8 C 4 H8 O4. Right. We got about pentoses. Pentose, we have got, this is the pentose. Pento means pentagon, 5, 5 corners, 5. So the value 5. C C5 H10 O5. So this is how you'll be making formulas, and these are all monosaccharides, and the differences of the all the differences are coming due to the presence of uh, the carbon atom in them. So we have got hexoses. uh, this is the most important group. Remember this is also kind of important, and this is the most important. We're looking into studies of hexoses in most of the cases, and this is most important. And you just see glucose is here, so this is very very important. Like glucose is very important. So from here you get to know that uh, hexoses like C6 H12 O6. So you may be thinking that this is the formula of glucose, but do remember this is a general formula. We can have glucose of this formula, we can have galactose of this formula, we can have fructose of this formula, we have got other compounds as well. So the only difference is the structural basis difference, and we will be looking into how the difference is. Don't take attention about that. We got heptosis, hepto7 C7. This is the final group, C7 H14O7 H14O7. So I do hope that you've got the classification of the number of carbon atoms, and let's get into what's aldoses and ketoses. So I would make you understand what aldoses and ketoses is by the hexoses, by this term hexoses, because that would be helping you a lot in different ways. So so let me draw, like we have got classification. You need to remember this, like what sort of monosaccharide is in aldoses and what sort of aldosaccharide is in ketoses. But this is the most important. You need to know. You can leave others, but this you need to remember. This is very very important, very 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 important. And you need to understand this ribose kind of, this is also important in the pentoses. Others are kind of not on our syllabus, they are just mentioned, but we are going to study the hexoses in detail. So that is mentioned like glucose and galactose, aldoses and fructoses, ketoses. uh, Let me draw the structure of glucose. Like we have got C6, like C6. Remember that you need to know chemistry a bit if you are in the field of biomolecules. C3, C4, C5, and here is the C6. And length, we'll be making bonds in between them, connecting carbon atoms with one another. And this is C6. Let me write it for you. Like you need to understand this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. From here you need to look that you need to agree that this is C6, right? This is C6. Now we have the C6H12, right? In the aldoses we have got formula that C6H12 hexo 6 and H12. The H12 would be like you need to remember this the first would be like this H, and the H would come mostly on the right side excepting the carbon 3. So H would be on this side in carbon 3 position, and you will get to remember these things when you as much as you practice as you do. And this is just the beginning. We're looking into more details and how this formed and what is happening behind this, looking all so this is just looking into the differences between uh, we have got similar formula CCH12O6, but we've got difference. One is aldoses, other is ketoses. So here we have again H on this side. We have got only the difference on the C3. Do remember that in the glucose. So C5 here is also H, and on this that we have got a constant thing, that is H2OH. H2OH. This is kind of particle. Now we have got wait we have got double bond oxygen over here. So this is permanent. You will look that this is permanent in almost all monosaccharides. This will not change, and this will not change. So the only difference would come in this four atoms, and so H and OH will come on this side like this, and OH will come on this side over here, and OH will come on this side over here, and OH will come on this side. So this is the basic structure, the linear structure. This is line type of structure. We have also got ring shaped structure that will be all coming. This is kind of a deep sort of chapter, and we will be learning it slowly, making clear the concepts. In today's video we are looking into the aldoses and ketoses. We have got you can count the H and OH. You will find that we have got the C6H12O6. You can find if you want C6H12O6. We have just filled the valencies all around, and you need to remember like this is constant. This would be the same. This is constant. You just need to remember this, that C3 would be changed a bit while the others would be the same. Now the only difference between the aldoses and ketoses is in, you can say, in this group we have got a difference in this group. This group of the monosaccharide shows that this is this group shows that this is aldoses. Like if any hexose sugar is having this, if any hexose sugar is having this pattern of carbon first, this means that this is the, you can say, this is the aldoses sugar, or this is aldoses. Now we're going to move forward to the next part of the ketoses, and in ketoses we have got another difference, and we're looking into that. Here we have got the so I'm back. The video was quite being long. I was just shortening a picture. So let me tell you a thing that you will be shocked. Maybe some of you get shocked. Like this is also C6H12O6. C6H12. The structure that is present above is C6H12O6. H12O6. How would you guys believe? Like these both structures are same? Not. This is glucose, right? glucose, right? So as I told you, this part shows that this part would be showing that whether the structure is aldehyde or ketone, or the first see first. So if you do see here, we have got a change. So what is the change? We've seen that the oxygen double bond has moved from carbon first to carbon number 2, and this is the change which shows that this is ketone in whatever monosaccharide or any other compound. If you see the double bond of oxygen on the second carbon C2, that means that this is ketone sugar. And we have got a full the file valency, like over here, see 1 valency, 2 valency, and 3 and 4. This was completed, like 1 2 completed, 3 and 4 also completed, this is also completed, and here 1 is completed, 2 3 and 2 is completed, 3 4 also completed. The valency are completed and they are all stable. There is just a difference in structure, and this is the same as I said. This would be the same in all cases. This is the rather structure is all the same, H, OH and OH. This is all the same. The only difference is over there. So this means they both have similar structure, and this was the reason I just took this example. But there can be differences this as well, but you need to look into the carbon first. If this is the oxygen bond, double oxygen bond is the second carbon, this is ketone, and the first you know, the aldose, like over there, this is now known as fructose. And uh, you may have a question like that would clearing your concept as well. Like we have got in the examples that there is galactose also, aldoses. So what would be the difference in galactose? Like if this thing is same, the C first arrangement is same, so what would be the difference between the glucose and galactose? So there comes a point that there would be a difference between the remaining carbon atoms. This thing I was talking about. So you cannot say that this would be all same in all the cases. This can be different in different cases. This was the most simple example. In the further videos, you're looking into the glucose and galactose structure. When you're looking into hexose, one by one structure of every ketone and hexose, so you will get to know about how it works. Probably this was just an introduction video, and I do hope that you've got something, and meet you guys in the next video. Till that, goodbye.